Hey everyone, welcome to 76A. What is an exponential function? Today we're going to talk about what ways we can identify an exponential function. How is it different than a linear function, something we did back in chapter 5. And we're going to start evaluating them. So first off, an exponential function. All right, this takes everything we've done in the first half of chapter 7. All those exponent rules, exponents, exponential functions, seeing that connection there? Yeah. It's going to be a function where the independent variable, which is your x, appears as your exponent. So the x is your exponent. And here's what it looks like. But before I show you, the linear function is y equals mx plus b. All right, that's the standard, pretty much the slope-intercept form of a linear function, y equals mx plus b. What I'm about to show you is the same kind of just the basic form of an exponential function. All right, it is y equals, do you see that little dot there before? Did you? Y equals a times b to the x. All right. Lots of rules though. A can't be 0 because if a is 0, it cancels everything out and it kind of nixes and then it can't be exponential. B has to be bigger than 0, okay? Meaning it has to be positive, but it can't be 1. Any thoughts on why it can't be 1? It can't be 1 because if we have 1 as my b and the exponent, pick any exponent you want, b, which would be 1, so 1 to any exponent you want will be 1. Therefore, it wouldn't be exponential, it would just be linear. All right, so that's why b cannot be 1. It can be any value bigger than 0, but not 1. And then x, your exponent has to be a real number. Okay, so let's do some examples, some more in-depth information. So this table shows an insect population that increases over time. All right, at time 0, meaning like the initial part of this, it was 2. At day 1, it was 6. At day 2, it jumped to 18. At day 3, it went to 54. Do you see any what do you notice about the population? What do you see happening? Hopefully you noticed, oh look, it triples. 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. All right, see that these changes, we don't want to call them constant changes because constant deals with linear, adding, subtracting, but these do have the same increase, but they're tripling every time. All right, that's how exponential functions show up in a table. They're still patterns, of course, but they are multiplying by the same amount every time. All right, so the way we would write this table out would be, move myself again. I'm always in the way. The f of x would equal 2 times 3 to the x. So the 2 is my a. If I go back to my starting basic exponential function, y equals a times b to the x, 2 would be my a. All right. And if you look, notice 2 is the starting population. When x is 0, that is my starting population. So the initial, kind of the initial starting value, the initial amount is a. All right. And the b value is what it is being multiplied by, how much it's increasing by what multiple. Okay. This is an exponential function. All right, so now we're going to start comparing linear versus exponential. So look at this table. Does it represent a linear or exponential function? And real quick review. Recall that linear has a constant change, but it's adding or subtracting. Okay, so look at A. Do you think it's linear or exponential? Hope you said exponential. All right, my x's are going up by 1. Great. Now my y's. If I look at patterns here, I can see it's not going to be the same adding or subtracting. So I could try this out. I times it by 3, times it by 3, I times it by 3. I don't care if they're negative or positive right here, right? It's tripling every time, all right? So this would be an exponential function. And if I wanted to write it out, it would be y equals -1 would be my a times 3 to the x power. That is how I would write it out. Sometimes you might see it written kind of like this or with different parentheses in places, but that's how I would write it. All right. What about this rule right here, this equation? Is it linear or exponential? And then explain. What do you think? Well, this is going to be linear. The x is not an exponent. This is actually y equals mx plus b, where the b is just 0 and the slope is 3. All right, this is a straight line, constant rate. What about this one? Take a second to read this and then answer what one you think it is. I hope that you said it was B. All right, choice B. All right, now on to ordered pairs. Just like a table, but now it's written a little differently. I can look at my x's, my x's are going up by one, by one, by one, but now my y's. Look what's happening to my y's. What's going on there? I know it's where they're always times 3. It won't always be times 3, I promise, all right? But since they're tripling every time, this is going to be an exponential function, yes. The reason is it's tripling. I could write it as y equals, my starting amount would be 4, because that's when x is 0, and then times 3 to the x power. I promise it's not always going to be tripling, but it's just it's nice to work with tripling or doubling in the very beginning of these, all right? Now, let's get to some evaluating. The initial population of 20 rabbits triples every half year. All right, half year. Here's the function of what it looks like. All right, my first question is, how many rabbits were there to start with? Good, hopefully you said 20. And then it says triple, so that's the 3 to the x. All right, that's in how many half year periods. How many rabbits will there be after 3 years? Before you dive in, what will our exponent be here? If you said 3, the reason it's not 3 is because that's 3 years. X represents how many half years in this case. So how many half years are there in 3 years? That's right, there are 6. So all I'm going to do is I'm going to enter this in the calculator very carefully. 20 times 3 to the 6th power. And when I do that, you get a lot of bunnies. All right, I'll show you. I'm going to do 20 times 3 to the 6th power, and you get, oh, where's my camera? 14,580 rabbits. Oh my gosh, that's a lot of bunnies. All right, evaluate these, see what you get. Hopefully you got them, you can get them right. And if you don't understand why you did not, reach out to me, but enter it carefully in the calculator using the exponent. All right. And here's your work. You got an IXL, X1. The Khan Academy is comparing linear to exponential, and then you have your mastery check.